Okay, we move on to another example, which is on page 56. This one talks about how you can draw enthalpy change cycle. So the question on page 56 has been mentioned like this. So they give you the intermediate steps which we require to form the final equation, which is zinc plus sulfur equals to zinc sulfide. So they want to find the formation, enthalpy change or formation of this one using these three. So the approach is the same. The one we want to form, we will always write it at the bottom. And then the stuff they have given us are these three. And then using the same approach as the previous example, we will be able to identify the enthalpy change. So first thing, zinc. We have 1 mole of zinc on the left, and then we have to check one by one. The first equation, zinc is on the left. And this one does not require to be changed, so this is okay. Next, we move on to sulfur. Sulfur is second equation, does not have. Third equation, sulfur 1 mole, yes, so we do not have to change these two as well. And finally, zinc sulfide is on the right side. However, what we need is on the left side. So this equation needs to be flipped. And then ask ourselves, do we have to divide it by or times 2? We don't need to because the mole is 1 to 1. So we flip the whole equation, we'll get zinc plus sulfur dioxide equals to zinc sulfide plus 3/2 of oxygen. So we have to flip sign, so we become positive 4, 4, 1 instead. So we get rid of this one. And we got zinc sulfide on the right. So now we got all the things we need. So double check if we can cancel everything. SO2 and SO2 canceled. 1 and 1.5 and 1. So 3/2, 3/2, 3/2 and 3/2 canceled. Zinc oxide canceled. Now why didn't I cancel now? Because we need it later on for drawing enthalpy change cycle. So essentially we just add them all up. So we got negative 348. This will become positive 441 minus 297. And we will get the answer negative 204 kJ per mole. Why per mole this time? Because the question has given us the unit as per mole. Now this is not the final answer. We have to draw the enthalpy change cycle. How do we do so? It is quite tricky. It all depends on this one. So if you mess this up, your enthalpy cycle will be also messed up. So first thing, we have to draw three things. 1, reactant, product, and intermediate. The arrows are not always the same, but for this one is always the same, which is going this direction. So what is the reactant? The reactant will be these two. Zinc, sulfur, solid, plus sulfur, solid, become zinc sulfide, solid. Okay, this will be always this one. Now, next we have to ask, which questions were not flipped? That means, did we flip the equation? We did not. So we look at the first one. The first one is zinc combines with oxygen to gives out zinc oxide. So zinc is over here. So we combine oxygen, which is 1/2 of oxygen, which gives out zinc oxide. So zinc oxide, we will write it over here, which is solid. Next, sulfur. Sulfur reacts with oxygen to gives out sulfur dioxide. So sulfur is here, reacts with oxygen. So we have 1/2 oxygen. Sorry, this is 1 mole. 1 mole of oxygen to form sulfur dioxide. So there should be 2 lines, but we just merge them into 1. So you will realize that what do we do with half of oxygen here and 1? We just have to combine it to the top to become 3/2 oxygen. So these two will become 3/2 oxygen on the left. Now the arrow is going down this side because it's a negative reaction, both of them. Okay, so that's why it's going downwards. However, for the zinc one, remember we flipped the zinc equation. So it's no longer from here to here, okay? Since it's flipped, so we have to go return direction. All right, reverse direction. So flipping means reverse. So we have to look back. Zinc plus 3/2 oxygen. We ignore this first. Zinc will form into zinc oxide and sulfur dioxide. Let's have a look. Zinc will form zinc oxide and sulfur dioxide. That is correct. So where do we add the extras 3/2? We add it next to it. 3/2 O2. Now you will realize that, sir, if you look at this equation, there's no 3/2 oxygen. Now you realize we can actually cancel it. So adding it and not adding it will not make a difference to the overall equation. But in this case, we have to add it because we have to balance this equation. And that's how you draw the enthalpy change diagram cycle. It will be confusing at first, but the methods are always the same. So let me repeat. The first thing we have to draw 3 boxes. The first box, the arrow will be always this side because it's not flipped. It's going same direction. Zinc, sulfur, and zinc oxide. Then we have to ask ourselves, zinc forms into what? Oh, zinc oxide. Is it, did we flip the equation? No, so it's going this direction. Anything else to add? Yes, half of oxygen. Next, sulfur. Add with oxygen to form sulfur dioxide. Did we flip? Nope, so it's the same direction. So we write sulfur dioxide over here. So 1 mole of oxygen. 1 mole plus half mole equals 3/2 mole. We write it on the left. The last one. Zinc sulfide. Since we flipped the equation at the beginning, so the arrow will be also reversed. Instead of going from here to here, it'll be going downwards. So we just have to follow the what's written. Zinc sulfide plus 3/2 will form zinc oxide and sulfur dioxide. If you make these two correct over here, you will realize this will be automatically the same. So you don't have to even think about it. And that's how you draw it. So remember, you have to write the states clearly. Again, I did not write the states. So just ensure the states and the mole is the same. Now, okay, so that's pretty much for example 35.3. So please at home, can you do practice 35.2, question 1 on page 57? Okay, and question 2, we'll do it together in the lesson time. Okay, so that's it for this video.